Hello everyone. For this project, I decided to talk about the post-silicon era of computing. If you've been to the store in a while, you've realized that the speed at which technology is advancing is progressing exponentially. This exponential growth was predicted by Gordon E. Moore in 1965. He noted that the number of components in integrated circuits doubles about every 18 months, and this became known as Moore's Law. At the rate at which our civilization is currently progressing, we will soon see the collapse of Moore's Law and have to turn to non-silicon based computing methods.
Because eventually physics takes over. And that is, physics says that silicon is unstable at the molecular level. Transistors get so small, so powerful, and they generate so much heat that the silicon chip melts and electrons leak out because of the Heisenberg uncertainty principle. You don't know where the electron is anymore.
With the basic computer element, silicon, becoming physically insufficient, mankind has turned to the microscopic realm for answers. These answers vary widely from DNA computers, protein computers, optical computers, but most significantly, quantum computers.
Quantum computers compute on atoms, not silicon. They are as small as you can get in terms of information storage. You can't get smaller than an individual electron. And they work by looking at the spin and the orientation of electrons. If I put an electron in a magnetic field, it can spin up or it can spin down. That would be a 1 and that would be a 0. But in quantum mechanics, it could also be in between 0 and 1. So a bit 1, a bit 0 can become a qubit, anything between 0 and 1.
However appealing it may seem to compute on atoms, a quantum computer is far from being on the shelf.
The problem is interference. Cosmic rays, a rumbling truck outside your door, small tremors in the earth, they create vibrations sufficient to destroy the spin of the electron. And that's the problem. That's the reason why we don't have quantum computers. And remember, if you can solve this problem, if you can create a quantum computer that computes on individual atoms and electrons, you would be heralded as the next Thomas Edison.